Hey everyone, thank you for attending my talk today. My name is John Bent. I'm a senior director in Seagate Research, managing a portfolio of projects into data infrastructure, sort of the evolution of the data sphere and data centers. Today I'm going to be talking to you about some work that we're very excited to be doing, partnering with DAOS and building some solutions together. All right, so first I'm going to just start with something that's always sort of intrigued me. I'm not quite sure exactly what it means, but I find it sort of eerily similar. So I think there is some meaning in this, and I keep hoping one day somebody will tell me what it is. Maybe today I'll get lucky. So once upon a time, there were two small Lustre startup companies, WhamCloud and Xyratex. And right around the same time, 2012, 2013, these two small Lustre startups were acquired by large non-HPC enterprise companies. WhamCloud went to Intel, Seagate went to Xyratex. Right about the same time, in 2012, 2013, both of those Lustre startup companies, while being after having been acquired by their large non-HPC parent enterprise companies, spun off next generation object storage systems out of fear that, POSIX will not continue to scale forever, that Lustre in particular was going to be limited by some of the unnecessarily strict constraints of POSIX compliance and semantics. So they spun off these next generation object storage systems, DAOS and CORTX. Then, right about the same time, 2017, 2018, both of those large enterprise non-HPC parent companies said, we don't like this HPC storage stuff that much. It's sort of a pain in the butt. The customers are too demanding. The margins are too small. We don't want these, Lustre assets anymore. So both of those parent non-enterprise HPC companies sold off their Lustre assets. WhamCloud went to DDN, Xyratex went to Cray, but they both kept their next generation object stores. So again, I find that very interesting. Not sure exactly what it means. But I do think that really ultimately what you ended up with was two systems that were highly complementary and really identical, and they both fit the same definition, right? What is DAOS? What is CORTX? They are both scale-out resilient object storage, uniquely optimized for parent company storage hardware. Right, DAOS is uniquely optimized for Optane, and CORTX is uniquely optimized for mass capacity storage, and specifically to be built on top of reliable hardware. So RAID enclosures as opposed to JBOD. It's one of the differentiators of CORTX. Okay. So they're really highly complementary. What you're looking at here is a graph. The graph is a little hard to explain. What this is all of the bytes stored across the top 100 cloud service providers. So every cloud service provider from this set of 100 shows up as a horizontal slice in this graph. So just to sort of help show this, there's one company, right? And at the very top, you can see here's a company. Here's a company that at the very top, and the height of each slice is proportional to the total number of bytes that company has relative to all the bytes of all 100 companies. So the highlighted company is obviously one of the bigger companies. At the top, you see a very small company that has 100% of its bytes in disks. At the bottom, a very small company that has 45% of its bytes in disks. So what does this show overall? It shows that, hard drives remain dominant in storage, but, well, except for that tiny weird little slice at the top, everybody also has some form of high performance storage, right? And so in the same way that it's a reality that the world has different storage media for performance and for capacity, we believe that the world needs different software. So that's where we thought for a long time that DAOS and CORTX are highly complementary. So if you sort of look at bandwidth, IOPS, latency, mass capacity, file, S3, going after enterprise, going after HPC. This is the first time that my friends at DAOS have seen this slide, so I don't know if they'll have disagreement with anything, but I think it's certainly reasonable. You can see that nothing quite satisfies everything. But we do think that the combination does, with maybe some question marks about S3 and maybe some question marks about enterprise for the same reason that there's question marks in S3. So spoiler alert, one of the things I'm going to be talking about today is addressing that lack of S3 in DAOS, which Johan mentioned earlier. Okay. So, what are we thinking for DAOS and CORTX? All of the main applications that people are talking about today, AI, ML, big data, HPC, all of the main frameworks. Actually, Johan had a better list than what I have. So Johan, I'm going to have to borrow that slide from you, please. Thank you. And protocols, S3, POSIX, lib, DAOS. And we sort of think that small file IOPS, also latency workloads, go to DAOS on top of Optane. Yeah, I know I keep saying Optane and y'all are thinking, hey, John. Okay, but hold on. An object bandwidth and capacity workloads going into CORTX, right? So that's Seagate's S3 mass capacity storage platform. However, right, so here's the way that the world was. Two things happened within the last 6 months. So one of the things that happened is Optane has been killed at Intel. There's still, what's up, Andre? Did I break the microphone? Okay. I think it was something that Dean did when he was giving his talk.
Okay, the third one.
Oh, gosh. Like Dr. Octopus.
Arnold.
And the other thing that happened recently is Seagate made a decision to de-productize CORTX. We are going to continue to support the open source community. There's a lot of really cool research projects going on around CORTX in EU, but we are going to focus on our live cloud for our object offering and de-productize CORTX. So maybe the future is dimmed, right, for DAOS and CORTX as of 2022. Yeah, and those two things happened at about the same time as well, right? Remains very mystifying. So I think that the future remains bright. It's just a little different than what we were thinking. Instead of CORTX as the back end for DAOS, instead of doing S3 tiering, we're going to use our core vault system, still get a lot of the gains for the multi-level erasure coding that we believe are really important. I'm not going to go into that in this talk. But we've done a lot of research recently. This is also echoed by Lionel doing MARFS. Anjus has been working on this project with us from Oak Ridge. What we have discovered is that for the same capacity overhead, if you split your erasure across 2 levels, you get better durability, right? So the math isn't perfect, but instead of just doing 8+2 at the network level, if you do 8+1 at the network level on top of 10+1 at the hardware level, it's the same total capacity lost to parity protection, but you get better durability, more 9s. So that's what we're continuing to do. And instead of Optane, CXL plus question mark, maybe SSD, maybe something is going to show up. I think Samsung just had some announcement, about word addressable DRAM packaged with SSD and tiering and batteries. Yes.
So what's the interface to the access protocol?
Block. Yeah, it's like hardware RAID. It's your dual controller typical hardware RAID. But the idea is that we'd have a lot of them, and DAOS would do some level of erasure across them, and they would do an additional level of erasure within them.
Back to my question then, is this tiering or is this caching?
What's the difference?
Is the block in 2 places, or is it in 1?
Oh, that's a good question. The question was from Dean Hildebrand, is it tiering or caching? To which I asked, what's the difference? To which he replied, tiering means the block is only in one place. Caching means it's in two places. That remains to be seen. I think probably caching would make a lot of sense if, certainly for the worm containers that Johan talked about earlier. Oh, and then, Wither S3. Okay. So, in case you're wondering, my boss certainly wants to make sure that Seagate's got a motivation to be spending our time here. What is our motivation? It's hard to go to any talk about data, although I haven't seen this yet today. Oh, that's because DAOS is not a capacity storage system, it's a performance storage system. When you talk about capacity, you talk about the world's explosion in data, right? So much data being produced. One of the things that's interesting as we dug into this data, this is a graph of the data being created in the world. And what we're seeing is that as a percentage of the data being created, which is also being stored, that percentage is diminishing. So the bright green at the bottom is the percentage of the data that's being stored. And it's also rising exponentially, but it's not rising to the same exponential scale as the data being created. And so you might wonder, why is an increasing percentage of the world's bytes being thrown away? Maybe there's more junk data. And we don't believe that to be the case, right? That it's hard to know for sure that data is junk, right? On the one hand, we don't need a video every time the neighbor's cat walks by my doorbell, saved forever. But you never know, right? It could have been an Amber Alert kidnapping victim that was, driving by, right? So it's very hard to know. And I think as a simple thought experiment, if it was free to store all of the data that you ever produced, you probably would store it, right? You'd also want some ability to quickly search it. You'd want, some reliance and reassurance about the security. But if it was free and easy, people wouldn't delete anything, right? So why is an increasing percentage of the world's data being thrown away? Here what we have is a very simple stack, right, of what does it take to transform thousands of hard drives into, a self-healing data namespace. And the size of the boxes in this stack are actually sized proportional to the typical cost for a data center and storage installation. So we took a couple of bills of material that our sales departments put together, and we sized these boxes. And what we discovered, right, is that less than 25% of the budget is actually going to the storage. And we have a biased perspective at Seagate, but we think that everything else is overhead, right? What does a customer want? A customer just wants to store data. They just want to be able to buy storage devices and use their money to buy storage capacity. And way too much of the money is going to other stuff. And so this is why we're really excited about what Intel is doing. And why we were previously really excited about Intel's vision of free software to help the world, buy and utilize its hardware better. Because that's what we're doing at Seagate. And why we're so excited about open source. How am I doing on time? Okay. I'm like a tenth of the way through. Okay. So this is a graph that shows, why are we excited about Core Vault? And Core Vault is a vehicle that, in the same way that Dean is saying, people want the easy button in Google Cloud, right? People want the easy button for provisioning their hardware. And what this graph shows is when it's time on the horizontal axis and the cost on the vertical axis, and there's two lines, and it shows this gap, right? And what it shows is for each of our generations of hard drives, how quickly do they make it into data centers? And what we've seen over and over again, right? And we know, right, that one 20 terabyte hard drive is a more economic storage solution than two 10 terabyte hard drives, right? I mean, the slots have a per slot cost, and you just get economies of scale, okay? And what we see is when we release a new hard drive on Tuesday, it's in the hyperscalers on Wednesday, they've got it in immediately. But for some reason, like our enterprise OEM customers that have to qualify things, it can take them up to 2 years to get our latest, greatest hard drives into the hands of their customers. So that's a huge amount of economic savings that are being lost. All right. So, again, what is our motivation? And it's protecting hard drives in the data centers. And we don't like SSD, but we do like things, like Optane and CXL. So the same graph, and just for fun, what I did is I shaded 4 of the companies. Those are the big 4. People often talk about the big 4 cloud companies. I won't identify them precisely, but they do all 4 have slightly different ratios. They're all super close to 10%, but slightly different ratios. And so I was talking to somebody from one of these companies, and I said, hey, I noticed that you have a better ratio, right? And it's really a better ratio from Seagate's perspective as well as their perspective, right? Because dollars per byte are better with hard drives than with SSD. So I said, you have a better ratio of hard drives to SSD than some of your competitors in the cloud space. Why is that? And I said, I'll tell you why it is, because I know better than you about your company. I said, the reason why it is because your cloud runs more compute-intensive jobs with stricter, latency SLAs. And the person said, no, John, you're wrong. The reason why is because we're better at building architectures, that we're better at extracting every last ounce of performance from each and every hard drive that we buy. Because why do people buy SSDs? They buy them for performance. Well, hard drives also provide performance. And if you can use all of the available performance efficiently in the hard drives, you need fewer SSDs and you have a better overall economic data center. So some of you have seen this before. I'm repurposing it. There's this guy, Mike Lang. Who knows Mike Lang? Oh yeah, Quincy knows Mike Lang. What'd you think? Curmudgeon-y? That's fair. All right, great guy. I'm a big fan of Mike Lang. But the reason I like Mike Lang so much is he's really smart and he understands HPC and he's mostly very generous with and friendly with his time. But he's a bit curmudgeon-y. And I over and over and over have conversations with him to follow the same pattern where I say, Mike, I have a question. He says, you're an idiot. I say, okay, fine, but can you just, and he does, right? So I take some abuse, but I get the answer and it's worth it. So one time I said, hey, Mike, I got a question. It's all about HPC tiers. Do you want 3 petabytes and then 30 and then 300 and then 3,000, in the various storage media? He says, you're an idiot. So I say, okay, fine, but can you answer the question? He says, look, we don't want tiers. Tiers is just an unfortunate accident to economics, right? All we want is infinite memory and a reliable computer, right? And so, he came up with this thing, the fewer tiers, right? He said, maybe that's simple enough for you to remember. And 4 minutes left. All right.
I checked your slides, you kept leaning.
I told you. And so I think, Mike's words were prophetic, right? So from the NERSC white paper, Storage 2020, we have one of the most esteemed authors in the audience here today. They are predicting a return to 2 tiers. Lano is also predicting a return to 2 tiers, right? And so the question is, how do we help them get there? And so I think there's 2 ways. One is squeezing out SSD from the bottom by doing what the person at the cloud company said, make sure you get really efficient utilization from each hard drive. And so Seagate is doing this. We're funding university research. Not all of these are funded by us. One is anonymous, but these are 3 research projects that came up with identified problems. They said, hey, multidimensional arrays in scientific computing cause lots of random I/O. The next paper, it's anonymous, it's under review right now, said, hey, compression and dedupe fragment data. That causes random I/O. Third paper said embedded vector tables in AI and ML have lots of cache misses, right? So these 3 problems. So what do you do about these 3 problems? Well, for all 3 of them, the bad solution for the customer and for Seagate, right, is, replace the hard drives with SSD, reduce the random penalty, to reduce the fragmentation penalty. to reduce the cache miss penalty. Or, the better solution is you can improve the software, right? Hard drives are well understood media. And in all three of these cases, it was possible, right, to write the software to extract all of the performance from the available hard drives and avoid the need for expensive SSDs. And then squeezing out SSD from the top, right? And so this is ultimately what we're doing with DAOS and CORTX. And so one of the first things that we noticed when we started looking at partnering with Intel on DAOS was, hey, DAOS doesn't have S3. And so coming from this enterprise company that was developing our own object store, at first I thought, wow, I really like those people, but they're like total idiots. Well, they need S3. Of course they need S3. And then I realized, of course, they're not total idiots. I think a lot of times S3 and HPC are somewhat anathema, right? They're sort of opposite concepts because as Johan said earlier, right? Object is slow and HPC is all about performance, right? I mean, it's embedded right there in the acronym in case you ever forget. But targeting enterprise, Seagate really does need S3, right? Because I think in what you saw with like MapReduce being one of the original sort of cloud programming models, it's really simple, easy to use primitives and just let the machine do the work. But in HPC, the programmers are willing to contort themselves to make sure that they get maximum utilization from the machine. The question was, is that a picture of Johan on the slide? The answer is yes. That is indeed Johan on the slide, and Kelsey is the other icon there. Okay. And then I'll just end with like a little silly thing that I sometimes think about, which is the original motivation, right, for DAOS and CORTX. Everyone's like, oh no, like file systems aren't scalable. So we said, okay, fine. And this is sort of like the original WAS object store. Just give me blobs of opaque data and I'll return the ID to you. And then I say, well, no, I need to give them names. Okay, fine, we can give them names. And, can I group related ones in containers? Yeah, okay, I guess you can do that. And can I nest containers in other containers? Well, not really, but you can sort of approximate it by putting slashes in the path. Oh, great, and I also need a file interface. Okay, well, so, like we went through all of this, but what was the one thing that we got? Well, at least we sort of got people to agree that maybe it was okay to have relaxed consistency. And then most recently, everyone wants object stores to be strongly consistent. So I think the people that are writing object stores are thinking to themselves, should just ask me to make file systems more scalable. But then that is the question for the DAOS team, which is, could you have just fixed Luster or was DAOS needed? I think the answer is that DAOS was needed. Thank you. Oh, wait, I'm sorry. I had another slide. Everyone was really excited it was over. Sorry about that. So we do need S3 for our target customers. And so we did a project partnering with DAOS and our friends at Intel to add the S3 layer. And we said, why start from scratch with the S3 layer? Ceph has a very good S3 layer. And just a couple of years ago, Ceph had something called Project Zipper, where they decoupled what had been a tightly coupled interface between their S3 layer and their underlying Rados layer, and made it so that it was sort of more like Romeo and an abstract interface, like we have in MPI-IO. So we took advantage of that, and we added a DAOS RGW storage abstraction layer. And John, in your slide showing all the interfaces, S3 is above file. Okay. Thank you. And contrary to Johan's slide, S3, we layered it very intentionally on top of the file system to provide true multi-protocol access. And so what's multi-protocol access? That you can write it as a file, read it as an object, or the other way. And careful, because there are object stores out there that claim multi-protocol access, But what they mean by that is that the same installation can have an object namespace and a file namespace. So it's multi-protocol access to the servers, but not to the data. So I'm a little annoyed that they've started to do that because now I have to say true multi-protocol access. That then is my talk. Thank you very much. Yes.
For the, bonus security.
The question was, how does security work with the Rados gateway and the DAOS implementation? And I was able to answer that question all by myself using the knowledge in my brain. And no, I'm just joking because I didn't know the answer. So actually it was Johan that answered. And the answer was, I still don't know. The gateway handles it. It's done in the shared layer. Thank you.